case, one normal. In this case, if the permanganate is one normal, so you will have 0,017 grams of hydrogen peroxide. Why? Because the hydrogen peroxide molecular weight is 34. Okay? And the molecular weight of hydrogen peroxide divided by 2 is 17. Okay? Is 17. And that is the equivalent weight of the hydrogen peroxide when is compared with the equivalent weight of the permanganate. Okay? So, the equivalent weight is the molecular weight divided by the number of electrons changed. How many electrons permanganate will change? 5. So the equivalent weight of permanganate is the weight of permanganate divided by 5. Because each weight of permanganate, when it's divided by 5, will react with the half weight of hydrogen peroxide. Okay? Don't confuse weight with mole. Okay? Because the reaction of mole is 2 and 5. 2 mole of permanganate will react with 5 mole of hydrogen peroxide. But the hydrogen peroxide, the weight of the hydrogen peroxide is 34. The weight of permanganate is much higher. Okay? And so you cannot compare the weight with the moles. Okay? That is the point. I have to put here the N instead of mole. Okay? I have to put N. Just to make this correspondence of permanganate and the hydrogen peroxide equal. Okay? Equal. So you don't worry about calculations, because when you read the milliliters of permanganate added, you have just to multiply for 0,017, and then you calculate immediately the grams of hydrogen peroxide. Okay? Is this clear? Okay? You just multiply the number of milliliters that you add, okay, with 0,017, and then these are the grams of the hydrogen peroxide in the volume that you picked up. Do not forget that what you picked up is maybe 20 milliliters or 25. And then to know which is the amount of hydrogen peroxide in 100, you have to multiply by 4 or 5. Depends. Pick up 25 or 20. Okay. Okay, let's do this way. Okay, let's see again this now, the beginning, not the calculation, the beginning, okay? Okay, so if you see carefully this part, okay, look, now he's adding permanganate and nothing happened, and there is the hydrogen peroxide. This is because the reaction is catalyzed by the Mn2+. Okay, so at the beginning the reaction is very slow, goes very slow, because there are no manganese ions present, because manganese ions will come after the reactions. Okay? So at the beginning you add permanganate and maybe you see that nothing happened. Okay? You just swirl a little bit and then add again. Don't worry, because usually the amount of permanganate is around 20-25 milliliters. So if you add 5 milliliters, nothing happens, okay? Then you add it. You don't need an indicator. Why? Well, because permanganate is red-purple, okay? Red-purple. Maybe it's a strong pink color because it's diluted. That one was a 006. Our is a 002. It's a 1/5. Then you will see this color that disappears. Why? Well, because permanganate is purple. But manganese ions are colorless. Hydrogen peroxide is colorless. So, as long as the hydrogen peroxide is in the flask, okay, and the reaction, okay, is that permanganate goes to manganese ions, and then the solution anytime will become colorless, okay, till the hydrogen peroxide doesn't exist anymore. So the first drop of permanganate, look, no hydrogen peroxide, and remains pink, remains purple, okay? For 30 seconds, because permanganate is very reactive, so if there are impurities, then you see that after half a minute, 1 minute, the solution goes back to the colorless, okay? So if the color is permanent, okay, for 30 seconds, let's say, okay, 30 seconds, then it's okay, the titration is completed. You can read the value, maybe add half drop, and see again that the solution will remain exactly the same. Okay, that is the point. Okay. So you will see that this guy is not making the titration. It's just showing you the color of permanganate and the permanent color of permanganate, and how at the beginning this color, okay, disappears, okay, immediately, and then will remain a little bit, and then more and more till the equivalent point. Okay, but it's a very fast titration. See?
As you can see, the potassium permanganate, which has a dark purple color, is used as a titrant, and therefore it's found in the product.
It's easy this way.
The hydrogen peroxide solution, which is colorless,
Because they are not analytical chemists.
From the color of the solution, you can see that potassium permanganate is changing color right away after hitting the solution. The titration should be stopped immediately after that the color of the hydrogen peroxide solution.
You see the flask is a lot of drops and so on. Okay, and that is the formula. Okay.
Plus hydrogen peroxide in it.
So the only good thing of this show is just the English pronunciation. Okay, I think we finished. Okay, if there are any questions, just ask me. Okay. And no, we finished, but I did not finish to explain what we have to do in the lab. Okay. Okay, so we were at the bring to the volume, the unknown sample contained in 100 milliliters volumetric flask. Okay. So do not forget that your volumetric pipette could be of 20 or 25. Easy with the one sign, you have just to make it going not totally, but in the tip. What remains in the tip will remain. You don't have to push or to spin. Okay, you don't have to do this. Okay, no. Okay. If you say two sign, two meniscus, that's okay. Okay, then you know what to do. Okay. You have to transfer this to a 250 milliliter conical flask and add about 150 milliliter of water. This is an important and let's say delicate, let's say this way, operation, because after the water you have to add about 20 milliliters of acid, sulfuric acid. So to add 20 milliliters of sulfuric acid, you have to take the cylinder, the 100 milliliter cylinder, and then you put 20 milliliters to the side. 20 milliliters, but not 20, 15, 25. It's the same. Yeah, you do it, you practice. Around 20 sounds good. Okay? This is diluted 1/4, but it's still concentrated. Okay? Then swirl a little bit because the sulfuric acid has a density of 1.8. Okay? So if you don't swirl after adding the sulfuric acid, there will be, okay, the solution will be not homogeneous, and so you could make a mistake, okay? And then titrate with this potassium permanganate 0,1 normal, okay? 0,1 normal, if you divide this value by 5, you have a 0,02 molar, but you don't need to do that, because in the formula, then when you read exactly the milliliters, you multiply these milliliters of this compound times 0,0017, okay, and then you get the grams. Where the grams? In the 20 or 25 milliliters, okay. Then you have to give us the grams in 100 milliliters, because the results in percent weight volume means grams in 100 milliliters. You are lucky, because the volumetric flask is 100 milliliters, and so you immediately can calculate, okay, this percentage of hydrogen peroxide. Okay, thank you. No? Well, you have to do the titrations. How many titrations can you do? With a pipette of 25, you can do only 3 titrations. With a pipette of 20, you can do 4. Okay, because the last one cannot be done. Okay. But if you do 4 with the 20, so you add less volume of the permanganate. So theoretically the error should be higher, because the error at the 20 milliliters is twice than the error at 40 milliliters, the relative error, okay? So it's up to you, okay? I suggest to do 3, because you are at the end of your activity, then you know how to operate. Be careful with permanganate. Permanganate is a strong, very strong oxidant, and if you touch it with your hand will remain dark, let's say, dark purple, but it's brown. Will remain brown for at least 15 days, 20 days, until your skin will not replace it. Well, you have to scratch it. Okay. Don't touch permanganate. In case some of permanganate falls on the bench, okay, just clean it immediately with a vapor and some distilled water, okay? So this is the last class for analytical chemistry lab. But at the end of your lab activities, if you want to meet for another time, just to discuss the results that you obtained, okay, we can agree, okay, for one other day, any day, provided, at university, just to see the results, the error, and the calculation of the evaluation, let's say, okay? And so you were asking one of these because of...
My friend is absent.
No, your friend is absent, yes. But I think there are also other people absent. So.